Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. Today I'm just hanging out. I've been working on our demo tool a bit. So I think last week we made a little bit of progress. Also saw how fast our compiler is, which is kind of cool. This weekend I made a bit of progress, not on much visible stuff, but now assets in the tool are not resolved relative to the tool directory. They're resolved relative to the project directory. Now, this doesn't mean that much in terms of, again, things that are visible, but now I finally moved all the assets for different demos into their own asset folders within each demo, which is pretty nice. The main thing was that this was like a bigger change because I had to go through all the assets and like distribute them to the different respective demo folders. So it was just really annoying to do, but I wanted to do it before doing a lot of the other changes I wanted to make. So right now what I'm working on is doing copy and paste, actually, in our editor. So I just finished cut and copy, and I'm about to do paste. So basically what this allows us to do is select several ops and either copy them or cut them with the respective key combinations. And of course, undo still works with that. And the cool thing is that we can then go in a text editor, for example, and just copies the XML, which I'm really happy with, actually. So I think this is a pretty good solution. By the way, hi to guys in the chat. WisterTube, Local Hoster Skeleton, Love Like Semtex, Repnop, Cluwash. Yeah, I gave the tool a tiny facelift some weeks ago, and I think I ended up merging it to master last week. But yeah, it just makes it a little more consistent. Kind of the look I was going for initially. But now that as things are maturing, it makes more sense to actually spend time on those things. But yeah, especially copy and paste is something that we really, really lack in the tool. For example, if I wanted to copy this thing that calls a function, then I should be able to copy and paste it a couple times, which is currently not something I'm able to do. So that's why I'm working on that. Now, the nice thing about it is that the implementation actually ended up being pretty simple. I did a bunch of stuff that goes, through the stack and exposes it in terms of like getting it on the window itself, being able to have a hotkey for this, and that's just a bunch of cute specific stuff that exposes these. And then did all the plumbing. And now I'm finally implementing this, and it's super simple. I just grab all the ops from the model based on the ones that are selected. I call this serialize ops to clipboard, which is kind of where the magic happens. Look, Oster says it's called yank and put. Got a Emacs man over here. And then, we'll clear the selection, recompile, and then put the change on the history with that version of the model. Copy doesn't have to do that. Because it doesn't actually change anything. So it just puts the ops on the keyboard. It also doesn't remove them when it goes and grabs them from the selection. And I was really happy with how easy this was because I found a crate for doing this that's called Rust Clipboard. Shocker. And it just does what you need it to do. It just gives you a very simple interface for getting and setting the contents of the clipboard as a string. And it also provides like the implementation context here for OS X, X11, or Windows. I believe those will also expose more specific things if the individual implementations can support those. So for example, if there's a more specific operation that the X11 clipboard can do, should be able to expose that. But for this case, I just need to be able to serialize and deserialize the strings. So we just create a little buffer, create an XML emitter. So this is using the XML-RS crate to serialize the ops using that into this buffer, make a string out of that, and then stuff that onto the clipboard. You'll notice a lot of unwraps here, and that's just going to be fine for now. Rust had loot crates, yeah. Someone should just make that loot-rs. It'll be the loot crate. The only other stuff I had to really do here is I had to go into my serialization, deserialization, which is not a lot of code anyway, and just split out this serialize ops part of it. So pretty happy with this. Just how non-intrusive this has been. But yeah, so I'm just going to do paste now, which should also be fairly simple. It's going to do a little bit more here because we need to, first of all, deserialize the ops from the keyboard. I'll probably make a little matching thing here. And in this case, it'll just return the ops. And then I'll need to, I want it to stuff the ops into the graph. It's here. Make sure that change is undoable. Update the selection to select the new ones. And yeah, and it also, when it grabs all the ops from here, it needs to sort of relocate them because I have position information. If I paste this, you can see that the ops have X and Y. And this X and Y is the exact X and Y that these operators had when they were in the grid inside the tool. I think it's best to just copy those out because you get exactly what you grabbed, which is pretty cool. But yeah, I want to relocate all of those so that like where you have the cursor is going to be the top left corner where things are going to be pasted to. So for example, if I open the editor, then I would, for example, right click here and then, or I don't have right click, but do this and then paste there. You can see that I did all the plumbing, so it does print paste selection at 2-1. So it needs to relocate all of those. It needs to deserialize the ops, relocate them to this position, and then do all the other stuff with the model. Should not be too bad. So in this case, we need to do this first so we can get the contents of the keyboard. I like to use the same variable names between these functions that basically mirror each other. Okay, move some stuff around here. I think it's just get contents. Yeah, get contents dot unwrap. With this particular tool, I actually do a lot of unwrapping because like it'd have to be pretty extreme circumstances for some of these things to actually fail. This one we might have to be a little more careful. In fact, actually, I know we will be. We will have to be more careful because this may not be able to get stuff from the clipboard if there's nothing on there, or it might parse wrong. So in this case, we're gonna introduce some error handling. I'm usually pretty selective only because it takes time to do. And usually when running into these errors, it's something I haven't implemented. One of those things you can kind of get away with when you're the only one using the tool. So it's that easy. Then I can do, like, I think the deserialized thing that I have didn't need to separate the ops stuff because it'll just have, it only looks for ops and expressions anyway. So I think this will be okay. Yeah, and that's the other thing I did earlier is I refactored all this to use results because I knew this was coming. So this should actually be relatively simple. In fact, I believe that's just closed it, but where'd it go? This is easily the biggest Rust project I work on, by the way. So there's a lot of scrolling through the file names and stuff. But yeah, this is gonna actually return the hash map, which is cool. It also returns this master position, which we're just gonna ignore. So first I'll do this without worrying about the errors. Serialize, and here we actually need to get, I actually need a reader from these bytes. Hey Andrew, I'm doing a copy and paste in our tool, particularly paste right now. So not that exciting maybe, but using the fact that we have so much time before the next party we go to just hammer down on some of this stuff. Yeah, so for this, did I close it again? Jeez. Bring it down here. Yeah, just need something to implement read. I think I can just do this. String.bytes. Might have to do something else there. We'll see. When we get the ops, this will be... Actually, that's all we need to do is just return the ops. We'll do okay. Ops. Worry about these unwraps later. And I know how I'll test for those as well. So we'll see that in a sec. But yeah. Here we go. This should be relatively straightforward. Actually, what we need to do first, though, is we need to relocate all of them. So I need to find like the topmost position and the leftmost position, which should be easy enough. Something like... I use X and Y, so we'll do that. Selection X, selection Y. Or do ops X. Naming things, it's hard. The nice thing here is we just need the position here. We don't need the op. Ops.iter. And I guess we can do if let's sum ref mute ops x. Oh. If pos.0 is less than, I think it's that. Not too bad. And then otherwise, then it's ops x is sum pos.0. Do that for y. Then we just need to insert these as far as I know. So I think yeah, we'll insert it and then we'll clear the selection as well. That'd be nice. That's cool. And then do the rest of this stuff here. And we're going to want to handle this as well in case this doesn't work, but for now we can test it like this. I'm pretty sure I messed up some references and stuff, so this will probably not build the first time. That's what I thought. Right, 366. Yeah, I don't know what the best kind of error we want here is. See what the clipboard thing returns. So I'd get contents here. It's a box with an error. I'm guessing this has its own error type. That's really common. I think this documentation might not be very good. We can just look at the source. Okay, so STD error. That's easy enough. May have to do our own error type for this. But we can worry about that. Just looking at the easiest way to get the bytes from the string. So I don't remember which function it is. Into bytes, that's actually exactly what we need. Reason I implemented for the vector, I thought it would have been. Let's see this. Oh, I need a cursor over the vector probably. Nice, look faster. Yeah, we don't have read for vec, but we can totally make a cursor out of it. All right, so we'll do pull the cursor here. Right, so I did forget to do the, when I insert the ops, I forgot to actually use these. So that'll be relatively easy. Grab the position, it'll insert it there. Now assuming we have any ops, which is an assumption we make if we hit this code and this code, then it'll be safe to unwrap these. So we'll just do that. Insert pos.0 plus equals ops x dot unwrap. No, we actually want to do this. Subtract the left edge and add start x with the right type. That's what we want. Didn't like that we didn't specify the type here to usize because that's what it is. And we need this to be immutable. Hey, tourist. Takes a little minute to build. But I suspect this will work for cases where we don't have errors. And it should be relatively easy to test the errors. The reason I'm using the clipboard like this as well is because, first of all, it does a lot of work for us. And second of all, I think it's really rad to be able to copy and paste in and out of the tool. Look at that shit. It does not select stuff right. It just selects the original positions. And I'm guessing that's just because of, yes, this has wrong selection. Oh, and they're even panicked. Very interesting. So we're gonna have to test this a bunch more. But yeah, specifically this selected thing needs to do this at insert position. I think that'll fix most of the issues because I'm guessing that crash, it was trying to unwrap some values that were in the selection because it does make a lot of assumptions that those are correct whenever it has to do anything. And because we created a situation where the selection was wrong, if I tried to, for example, copy out of that could cause some issues. So maybe that might be something else. We'll have to see where it comes from. But this did work. There we go. Now I just sit here and move stuff around. Look at that. Oh, she's a beauty. Grab all this stuff. Yeah. Look at that, guys. Look at that. Now, of course, we can undo all this. This makes me oh so happy. Oh, I just love how bulletproof this stuff is. That's why I love Rust. That is sexy. This will be very helpful. So that's it working with a lot of assumptions being made. This is all the stuff we copied. Pretty sick. That all just works. We can copy this again from here even. And paste it back into the tool. Just rad. So I can do something like new project. Just paste all this in there. So cool. I'm guessing, however, if I just copy a bunch of code out of the editor and paste that, then we crash. So that we gotta fix. That's the right reaction, Andrew. So yeah, so just as I suspected, pasting some random crap in there just panics here. And this was unexpected characters outside the root element. So I'm guessing that this was an XML error, and we need to handle that. The nice thing is we handle this in a couple places and just need to bubble it up. I'm gonna unwrap these. I'm gonna leave that there, and that'll be okay for now. And then this part, we're gonna bubble this error up here. So all I'm gonna do actually is just do the question mark thing here, and just only bubble up that kind of error, and that's gonna be okay for now. So instead of stdio error, it's gonna be cheeky as hell. Oh wait, we actually do need that. What was that? That was XML reader error. We can do, let's do that. Give us what we need to resolve that type. And that handles it there, but then we need to, that'll bubble the error up from here. And then we still need to bubble this up. Actually, you know what? I do want to handle this more generally. The more I think about it, there's going to be other cases here. In particular, we're going to have issues. I'm not too worried about getting the contents from the clipboard, but I am worried about this. Oh no, because that will actually get this as a string here. So maybe this is one we need to worry about as well. Let's do this then. Do that. I think we map error before that and it'll work out. I don't know why get contents boxes the errors. That's a bit weird. I guess because it could implement like the errors as a trait anyway. Because we're returning IO errors here, which is going to be good enough. So we'll do this. Just map the error. See if that checks out. Not of constant size. That's not the error I wanted. I think the IO results is what we want as well. Actually, we'll do stdio error. Let's write it that way. Bouncing around between things here. Kind of just stumbling instead of thinking through this properly, but that's going to be fine. Let's do it this way. I can probably look into error chain, but I don't want to right now. I'm not going to use it because I don't feel like reading about it right now. Which is a dumb reason, but I don't want to right now. I wonder why this is being so annoying. Must be because of the inner type here. Yeah, because that will take in the error. Let's just format this. Then do I still need to qualify this? I don't, so it's not. And then here we'll do the same thing. Yeah, that should bubble everything up. And then here, right here, we're also going to need to handle this. So the easiest way to do this is we can match on this. And we'll either get okay with the ops we need, in which case we'll do all this fancy stuff. And otherwise, we can do this. I think I'm even debug printing those errors elsewhere. No, we're good. And then we'll return a change and not update the model. Make it ticket to look into error chain actually. Because it's just straight up something I haven't considered. So now, if we, for example, copy some code from the editor and try to paste that, then we get unable to paste ops, unexpected characters outside root element, which is good enough. Good enough for me. Cut didn't seem to work. All of a sudden. Until I tried to paste over them. You know what it probably is? Actually. Because it does remove the ops. Cut selection here. Let me look into this. Yeah, it didn't redraw. I wonder if this is actually a general problem that this editor has. It probably is. Because almost everything you're doing, like selecting and stuff, the mouse is always here, and then it'll repaint when you move the mouse. This is probably just uncovering a case that I haven't considered before, which is if the mouse is off of that and then some other action happens to change the model. That'll be an easy fix. Because I can just go into the view, which is op editor. And when it updates... No, this actually should have done it, I think. So we would have gotten the update here. Schedules a paint event for processing when Qt returns to the main loop. This permits Qt to optimize for more speed. Yeah, so this is what it should be doing. Just double check we're getting this. much faster recompile when we just changed the C++ at the top. So we're gonna cut. Okay. Yeah, it didn't node update. Interesting. So why didn't that propagate? That's odd. Let's see, in the main window, this is where stuff goes down. And it should. Ah, that's why. It just goes through the context. That's wrong. We need to go through the mutator, which is actually going to propagate the events. That's why. Yeah, that's what I need. That should fix it. Not the project mutator, the scene graph mutator. Actually. Which are just interfaces over different parts of editing stuff. There we go. So sick. This will be very, very much more helpful. Because, for example, now I can go here and copy this subroutine to make a new scene. And have to update a few things here in order to make this use some things that are unique, but that's so much better than recreating all of these every time. Which is what we were doing previously. So I'm pretty happy with that. And again, still robustly handles pasting bad stuff. And I just love seeing this every time. Just how fast this goddamn tool is. Just click around in here, tap a bunch of keys. Always got to test this stuff. That's funny what kind of errors come up. All of this should be undoable. Yeah, fuzzing the node tool. Exactly. Oh, this makes me so happy, though. This is something I should have implemented a long time ago. I think I was waiting on some other stuff I wanted to do, but now I don't really see why. It's funny because usually when we're using this thing, it's usually pretty close to the party. And admittedly, I usually don't take the time to do general cleanups, just kind of build what we need. So it's good to take the time out and do some of this stuff. Just feels so good. Yeah, with this and the asset stuff I did this weekend, I'm pretty satisfied. I also realized I had a to-do on expiring shader assets. So like if you create a bunch of shaders and then didn't use them anymore in the graph, they would actually stick around in the asset manager. I fixed all of that yesterday as well. And I also noticed that we didn't have file watching on font assets. I fixed that too. And the last thing I did was I realized the file watching isn't actually case insensitive, which makes sense because it just watches for specific files and then checks, like when it gets file updates. You can only watch a directory. So when it gets an update for a directory, it checks, which files have changed. Or no, you can only watch a directory, but you can get events on which files changed. So I check if the file names match the file names I'm watching, and if they do, then I can update that asset. But of course, on Windows, when you load a file, it aliases in a non-case sensitive way. But then the watcher was just doing string compares, so I ended up fixing that as well. I posted a thing about that yesterday on Twitter, about the function I ended up writing to do that, which I'm not terribly thrilled about. But it totally works. And I am satisfied with this. Time to see all the places that this changed the code. Generally wasn't too many. That got ugly. The line for saving the model got super long. Here. Oh yeah, that's part of serialize here. Oh well, that's helpful enough. This won't be that long if I'm using my normal font size. Beauty. And this was a specific ticket that I had. Bam. Hey, Dark Second. There was actually one case here I did not test that I wanted to. And that was the case of like copying some of these ops. Just do a new file here. I just wanted to copy like one of these. And it totally works. Great. Oh, that's so cool. Pretty happy about that. Let's say we do this, for example. Just copy an expression. Oh, that actually crashed. I know why that is, actually. Oops. I totally know why that is. Found expression tag without op tag. Yeah, that's an error that the parser is giving out. This is actually correct for the parser to do this. So let's actually fix that. That's going to be coming from right here. Is it panics? That's stupid. I mean, that made more sense to panic before I did this change. So that'll be easy enough to fix. I think I can just do this. In fact, something like that. Whoops. Of course, this function spits out XML reader errors. I wonder if I can just make one of those. Yeah, I'm going to do it that way. Or you know what? Let's even do this. Oh, you can actually do this from an IO error. So if I did... Go back to this, and I can do dot into. Still kind of crap, but why not? There we go. Had to massage the types a bunch, but this will be good enough. I did do a quick Google into error chain. Looks a bit opinionated, which means I'll have to look into it more than just on a whim. So I'm glad I made a ticket for that. Yeah, so my test case here was just copying like a single expression, trying to paste that, and that totally works. Found expression tag without op tag. Beauty. And then I'll just amend the last commit. And force push to master, which you should do all the time. Please take my advice, definitely. Cool. Copying and pasting like a champ now. Burn, repo, burn. Linus Inferno. Man, I'm just super satisfied now. There's still other things that I would like to work on in the tool in the near future. Maybe doing this refactor primitive ops is what I want. So what this is, I'll just show you guys. When we draw actual primitives, right now I just have a set bunch of primitives that we can draw. If I can remember which ones they are. I think it's just these 5. Quad, cube, tetra, octa, and icosahedron. No sphere, no nothing. Just these. And what I would actually like to do, I think... Nope, it didn't work? Oh, the emoji thing, yeah. What I would like to do with these is instead of having separate ops for these, I would actually like to have one operator, which is just draw primitive, and then have it have an expression, which is which primitive it actually draws. Now this will break old projects, so I've been thinking about how to do this. Now the nice thing is this is actually why I waited for to do a lot of these things until I did the asset management stuff that I did earlier. And that was because if I just want to go change the project files by hand, I can just do that, which wouldn't be too bad in this case. Like there's a lot of quads, but that'll just be a simple search replace, I think. Might be a little more complicated than that, but won't be too bad. Another thing I considered was doing versioning on the project files and then doing like auto conversions. So like when it tries to deserialize, it'll detect the version and then upgrade. But I think that's actually a bad idea in light of this copy paste stuff, which has no way to detect which version it is. I feel like that'll get messy. No, I don't really want to move the primitives into a model file. I just want to change how these are expressed in the model in order to reduce the number of operators that we have, because then we'll have one operator and then you just change which type it is. I'm not thinking of extensibility here in terms of letting the user have other primitives, because it's 64K, so like having a limit on what kind of primitives you can have is the right move unless I start providing like a modeler, in which case the solution I'm thinking of actually would work anyway, because then you could have the name of a model instead of one of the primitives. So that would actually be a good idea. But I guess to show you in XML terms, this is actually cool because I can just copy this and then show you the XML. That's rad. So right now it's an operator at this position with the type quad. And then if I have all these other ones, you can see it's just a bunch of different types of operators. But I'm thinking more to do something like this. Type is primitive. And let's see if I can get one of these. And then, yeah, have an expression in here. See what I mean? So we only have one primitive operator type, and then it will choose which primitive it draws based on this primitive expression. That's what I'm thinking. So I might just do that actually, and then fix all our projects by hand. I think that'll be better because, like I said, when I like paste this stuff, the tool will have no way of knowing what the version of the thing I pasted is. RepNob, I could do that, but because this is a tool that only I use, I really don't want to have those kind of special cases. Like if I could, what I was thinking is if I could detect the version, which you can do if you see the whole file, because I could just start writing out version numbers. If you can detect the version, then you can do a simple upgrade that'll upgrade the version to the new version. Whereas if I just copy this operator, it has no way of knowing that that's the old version unless it like has a bunch of rules for detecting the old versions and then doing upconverts. So then if I change this later, then I have to do two conversions from the previous format and then the next format. Like it starts to add up in maintenance cost, I think. Maybe it wouldn't be that bad, but I'm totally leaning more towards just fixing the project files at this point, because I can do that fairly quickly by hand. If I had 1,000 users, this would be a completely different story. But that's not the kind of project this is. So I think I'll do that. So in that case, hey Alkama. In that case, go into demotivation. There are several layers that this touches. The first one is the compiler, which is the thing that takes those ops and turns it into bytecode. Now I'm thinking this change will only really need to affect that. It'll need to affect that, and then it'll need to affect some other code on the higher level stuff in order to... well, actually, that's all in this same project, I think. So if I run cargo test here in this Opus project, that's where the compiler is, which is just one of the projects that this tool is built out of. When it finishes building, it'll run all the tests I have for the compiler. And that's actually the only thing that I have tests for. because it's just where it makes the most sense to have tests. So in this case, here's the compiler tests. And literally just creates like a virtual graph here where you have, oh, at 0, 0, there's a quad op. And then the result is going to be a compiled program with this bytecode. And then all the other things is like empty collections. And then it just asserts that those are equal. So it's super straightforward to write these tests. But this is exactly the kind of thing that would change, right? So instead of quad, we would have op primitive. The bytecode would look something like primitive. And then, I don't know, probably just a single byte to identify that. So I think, how have I handled these in the past? Yeah, I usually put the argument here. I can do that. So let's say quad was 0. You just go in order. So this is what it would change. So what I usually do is I go in here and I change the test to say, okay, that's what I want to describe. And then I just go and fix all the errors. And it's awesome. So in this case, the cube would be a primitive with primitive 1. Actually, yeah, because the primitive needs the particular expression. How was I writing that in the other cases? Yeah, here I did this thing. So the primitive op here needs to know that it's going to be a quad. Something like this. So it gets really straightforward. And I think I just do these in order. But I love doing it this way. Because the compiler is really like the heart of the tool. You have the compiler, and then the model is really just some ops, the master position, a couple things like file name. And that's all you're really editing. And then there's a bunch of plumbing in order to get like knowledge of those edits throughout the tool. There's some stuff with like undo, redo. But really you're just modifying this structure, like a hash map of these. So it gets relatively straightforward. And then whenever I need to change these, I just do it in the tests, and it's that simple. Now, it will change a couple of these other ones. Like here I had double cube, and I'm guessing I was using those to test. Oh, I put 2 things in a row, and this is what happened. So we'll need to fix those up as well. And cube was 1 for the primitive. The ops themselves are almost an AST. The first thing the compiler does is look for adjacency between the operators and then builds an AST from that, and then it's a regular compiler after that. So they're close. This was Ep.029. I'm actually just going to run this again. So it'll give me a lot of errors, particularly about op primitive not being found. So I need to go and change a bunch of this. But it's not going to be too bad. I'm going to go into ops here. And somewhere down here we have like cube type name. I'm just going to get rid of all that. And this is just going to be primitive type name. Called primitive. And then we're going to have the defines for its expression as well. And I think this is my convention here. And we actually just need expression for primitive. It was also called primitive. We're going to draw a primitive, and then we specify which primitive to draw. Not bad at all. And then the actual valid values for these, I end up putting in the compiler. So this will be, that's the operator definition, like the actual type. And then here it'll try and create one from a type name. In the case of this, we want to match the primitive type name to a primitive, and default value ends up being this, and we'll do quad, which is by far the one I use most. And then we change some things here. And then this will get a list of the ordered expressions. It'll use this for various things. Kind of doing like reflection by hand here. That's not that bad. And these ones didn't have expressions. Just want to order these sort of the same way they were before profile. Something like that. And then when it goes and sets the expression, it'll do that by name. I think this code is fairly verbose, but it's just so simple. And this is the stuff that's backed by tests, so it's pretty nice. So we have the primitive. And then just like one of these other ones, we're going to match the expression name. There's only one valid one. And get rid of these. And then we run cargo test again. Now we got lots of stuff that's wrong. Because now it's like the parser and things in the compiler are going to be broken. So we're going to do a couple things here. This is the actual AST that these get turned into initially. So, oops, were they before profile? I do actually want to change that in here. I like to keep these orders consistent. Yeah, they were. Okay. So here, we're actually going to create a primitive type that we're going to parse that to. So here, text format, wrap mode, all that stuff, blend factor, and we'll do mod primitive. See, these are pretty straightforward. I think, right, because the actual bytecode needs these. That's why we have the conversions. The runtime will actually use these too. Same with the wrap mode doesn't actually. We'll see what we need. But for now, we'll just start with primitive.rs. I'll even not have that for now. So we had quad, cube. Just check the tests for the rest of these. Tetrahedron. Octahedron. icosahedron. There we go. Now we'll get even more errors probably, because now the AST type isn't handled either. Yes, didn't find primitive in scope here because we need to include that. While I'm at it, I've been reordering these to be alphabetic lately, so I'll do that here too. Right, and now it's actually in the compiler. This is going to give us some issues. So that was... Surprised the parser didn't, but maybe these are just in a certain order. I mean, we'll fix it all anyway. But yeah. Where was this complaining? 535. Right. So this is a variable scope visitor. This doesn't have any expressions. So this will be really straightforward. We just have to visit the children. So this becomes one of these. We have 670, which I'm guessing is the variable ref count visitor. So here we'll do the same thing. Uh, 784. Here's the syncref visitor. Again, we don't have any expressions, so a lot of these just go away. Nice and easy. We probably will need, or actually just the parser will take care of this, and then the primitive indices will be correct, so we don't have to worry about that anywhere else. 1370 is probably the code gen. And it is. So here, this also gets pretty easy, because we're going to have the primitive, and we're going to have the primitive itself here. And all we really need to do here is we push the opcode, we'll push the primitive opcode, and the primitive opcode will also take this argument. I think it just takes the primitive as is. I can't remember. This might be the U8 that we need here. It's in here. Yeah. Here we'll do U8 here. Or actually, these have like blend factors, so that'll be primitive then. Last stage there. So it's that easy. As long as I implement copy for this, then we're good there. Which I will do. So here, opcode, it didn't find that because this also needs to include the primitive thing here. Here. Yeah, there's going to be other issues with the tests, but the compiler will tell me all of this. Association and quad. This is it. Yeah. So now we're in the parser, and this is the thing. This is the very first step. So this is going to take the actual grid of operators and create this AST structure here. So this will be real straightforward. Let's go down to where it has these primitive ops, like here. And the thing is that the primitive we get here, here on the op, that's going to be a string, which is why we take it by reference. And we'll do let primitive is primitive. Should just need to do this. And then we pass some stuff to report errors if it needs to. And notice I'm not using try here because we have this question mark thing. So I actually kind of want to go through the parser here and fix while I'm at it. But actually, for consistency, let's keep it the old way. And then I can have another commit that will update that. That wouldn't be too bad. Just because that'll have so many small changes that are not relevant to what we're doing now. Once we get that, then we'll return a node data primitive from that object. And we need to do parse primitive as well. This isn't going to be too bad. We just look down here. It's stuff like parse matrix. And parse texture formats, parse wrap mode, parse blend factor. We just stick this at the end here. This will be primitive. So we have the string, the position, and the expression name, and the result will be a primitive or a compiler. And run this. This uses oh, what's it called? I don't remember the name all of a sudden. Nom. Uses nom. So we're just building up a bunch of parsers here. Easiest thing though is I just take these for the different types here. Quad will be primitive quad. Do the same stuff here. And again, I don't remember the last ones we had. Where's our tests? Here. Tetrahedron. Octa and Icosa. Here. Oops, here. That should more or less fix that. Looks like I missed a paren or a brace or something. And I did. We need to include primitive up here. Oops. And now this is why we need to do things like derive debug for the primitive type in order for it to produce errors, which is fine. and I'm probably going to need clone and copy. In fact, I definitely know that I will. The compiler relies on that in order to take this primitive by value. In this case, we now have opcode, which also needs to serialize these ops. Arguably, this is actually just an extra step, but I like to have it because it makes all these individual pieces so straightforward, even though there's a fair amount of text we have to change. So in this case, we'll have primitive. And the just as this. That's simple. This will be op primitive. Actually, we'll do push primitive like we do here. Actually, we'll do this. And constants here are going to come from another opcode file. And we'll get to that. But yeah, that should do that. Yeah, now it can't find those primitive whatever, because we need to go into the Opus runtime and the bytecode. So we need to push that. So in there, this is basically the bytecode definition for the actual runtime. So this is included in the 64K stuff. Let's do op primitive first of all. I'm gonna get rid of all these. Actually, we'll reuse these. Up here. And then make this be op primitive. And then we'll adjust all these. I could have also compiled these to the same ops, but I'd rather change this with the argument anyway. Doesn't make much difference. Now, we get a lot more issues with that. Because now we need to go in the JIT. Five, 6, 6. Yeah, here's where we have the ops. So here it did different implementations. I actually think I want to pull out the argument, push that on the stack, and then we'll call a primitive impl function. So we'll change it to that. So Bloop. So we need to do this. Should be something like that. I actually think you can push 32-bit immediates, by the way. (32-bit). Should probably go through and change that. Not that this is going to make much difference. Yeah, you can push an immediate 32. Opcode 68. I go through EAX. Can't remember why, actually. But I'll worry about that at a later time. In any case, this we'll call primitive impl. Now, primitive impl will actually take an argument now. Be U32, as we pointed out here. And then, yep, we need to go down to quad impl. It's going to become primitive impl. Going to get rid of these other implementations here. And then we take the primitive, which is going to be U32 here. And then we can match it based on these. Hey, Heiko. No, I'm actually going to change the projects. I'm going to go through the project files and change them. I was thinking about doing conversions, but when I thought through it, I realized I can just change them by hand. Because I also finished the refactor where all the assets are relative to the project directories now, so it'll be really easy for me to do that. But yeah, that is what I'm doing. I'll get copy and paste from the older projects when I update the project files, which I'm going to do after making this change. I'm just going to go fix them. Even if I did do backwards compatibility, I would have done that at the deserialization level, so all this still would have changed. So now we can match the primitive. And we can do so we had the in bytecode, we had the primitives here. Just gonna copy these. Whoops. And if we do this, could also supply these in an order list now, but we'll see. I think, so in this case, this code never panics. It's one of the caveats I have, or produces errors of any kind. So I'm faced with the choice to either make one of these a catch-all or do the catch-all as nothing. I think I want to do it this way. Yeah, do that. Let's see what's next. Right, because these are U8s, not U32s. Do that. It's kind of funny to cast this to U32 to pass this function, which then casts it to a U8. The reason I want to do that, though, is that I don't actually know the convention for pushing arguments that are smaller than U32s, if it still pushes 4 bytes or not. And instead of looking that up and remembering it, I'd rather just use 32-bit values on this boundary. And now we've got errors in the tests. So we'll go and fix those. It's actually cool if the tests just guide us through all of these changes. I don't think that'll be the case. I think there'll need to be some other things, but that's pretty rad. So this was 130. Right, because here we need to do op primitive. That's what like Semtex pointed out earlier. And then there are a bunch of these that use op cube, probably just for some like placeholder stuff. That's an easy thing to replace. Op cube was one of the first ops I had. In fact, we can make them quad now. Let's actually just copy out this part. And let's actually do this. Let's find the next one. Because I think if I do this, I think that just works. And the last thing I can do, get all these. Almost. That should do it. And they all passed. That's rad. So there's a couple more things we have to do in the tool. So this is a 32-bit rep op, but it'll probably do the same thing. Just it'll sign extend to 32 bits instead. So I figured it would do that anyway, most likely. And I don't mind doing it explicitly as long as stuff at that boundary needs to be really explicit in my head. So I'll just leave it as is. Yeah, so now the editor context needs to know about this stuff. This is stuff that's not covered by the tests because it ends up being so trivial to change this stuff. So it's this stuff here. So now we don't have any of these. We have op type primitive. We need to change this in 2 places. We need to change this here. Or a couple places, but there's a mirror of these definitions on the C side of things, which we also need to go check. That'll be in here, domain model C. And this becomes the same thing. These values have to match. And we missed another one in editor context. Why was that? 463. Yeah, this was creating the operator based on the type name. Whereas the other one was returning the type. And finally, the original model store contains a cube operator as it's in its default program here. We can make that a quad. It's actually an invalid program. That's the irony of it. In fact, I might as well change that. I think I can just do clear. What are my ops? What are my options? Clear. Oh, and this probably has a color. Yeah, that's fine. Clear it to black. That'll be a better default. The reason why that wasn't valid is because you have to bind a shader program. And since shader code doesn't come from the tool, I can't really provide a default for that. But this is fine. Let's do that. And I messed up a paren or something. Is it there? Oh, on all these I did. Dark Second, why did you go with an operator graph instead of a programming language-like solution? So I consider this a programming language, just a visual one. And I did that because when I was designing this, and the previous iteration of the tool as well, was geared towards not just me using it, but there was a buddy of mine who does 3D. We were thinking that he was going to use it as well. As it's kind of developed, it's making a bit less sense, but I want to do things like doing the copy and paste and other things like that to make the editor a little more comfortable to see, like just to kind of continue using it as long as we can. I'm leaning towards changing it, which basically just giving it a textual syntax. But I don't know if I really want to commit to that yet, so gonna keep exploring the visual stuff and see if I can make it nice to the point where I don't want to change it. Otherwise, I'll change it. But that was the reason. Now we've got some stuff with the view, because the operator editor is trying to make some stuff, trying to use these quads here. You can see there's a bunch here in the key map, which is actually one of the main reasons I wanted to do this as well, was to clear a bunch of these out. So we'll get rid of basically all these. And then there's going to be another one of these, which is where it's finding what color to give the different ops. In the view layer. But yeah, I mean, from the tools perspective, this is just a basic programming language anyway. Not much of a difference, except the very first parsing stage, and of course having this editor. So now our default works. Should be able to create a primitive with a quad, and this should actually give me parsing errors. So I don't actually print the errors, except I just dump the display thing to the console, which is fine, because you can see this is a perfectly formatted error. It even tells me where it is. The op becomes red. Unable to parse primitive, incomplete, size 11. So that's because it's an empty string. So if I start typing in here, we can see it gives me more useful errors. Cube should work, although now we're still getting invalid value because we're drawing a primitive with nothing. Tetrahedron will work as well, so that's pretty cool. Sphere will not, Good enough. So now I got to go and fix the projects, which shouldn't be too bad. So I'm just going to go into the Logicoma demos repo. The one I was testing with here was this green room project. And I can just go in there. We'll start with that. In here. So we can just search for quad, for example. There's actually going to be a lot of these. So let's actually search type equals quad. And this is going to be a simple change because actually it was a search. We need to select all these. So now it's going to be type is primitive. That should do it for this project, actually. I don't think there's anything in there other than quads. And it works. Sweet. But of course it works. Actually, there's one last thing I want to do with this before I go and change the other files. It just says primitive on the op. I'll show you that. Actually, you probably can't read that on the stream anyway. But it says, like when you see the different ops in the grid, it says primitive here. I want to actually display which primitive it is. So that's in, I think that's actually in editor context up here. Hey, Alpen, I'm working on my demo scene tool. Just doing some basic refactorings and that kind of thing. So yeah, it's right here because we get the operator text, and most of these, yeah, this is just a catch-all down here. I think we're gonna want this. Primitive ref primitive, and because this is just a string. This should actually be pretty easy to do. Also, I should really be using format here, shouldn't I? Yeah, not a problem. Like that. Did I? Did I, Henrik? That'd be pretty funny. Probably because I tried to do Control F or something. Wonder where I did that. Not surprised if I did that. There it is. Thanks for the heads up. If I just save the file out, it would be fine because it's. I'm guessing in that case it would have just been accepted as just a text node, and I'm just not reading those in the reader. So if I saved it back out, it wouldn't be written either. But now, if we open this up, the primitive here will actually say quad, cube, icosahedron also fits, which is nice. Cool. So I will actually save that just in case. Text shouldn't actually change. So there's one updated. Now I'll go through the others. Now I do actually have to swap out Rocket for a lot of these for various reasons. Alpen, thanks for the follow. Yeah, the next one, yeah, it's this wrath tracing one. So open the sync file for that. Yeah, green room isn't green. It was when I started it, and then I made it pink because pink is cool. going to be 05 even 507. So this is cool, because before I had to like switch branches to switch projects like this, but because of the refactoring I did the other day, it's not a problem. So here again, I'm going to do the same change. Watch the text editor bounce around a bunch. Being a little bit careful when doing this stuff because I don't want to lose my multiple cursors. Or have them get out of sync somehow. There we go. So there's that project. Only having to do quads here because they were doing like ray marching and stuff anyway. So I'll make a change, do that just to save it out again. Next. The green screen adds 10 pounds. Flip flop. That was the next one. So we'll do that. Search the same thing. Go and select all these. Probably could script this somehow, but this is fine. This is the 14th of May that I did this. It's kind of cool to go through these projects in particular because I did them on the stream. But yeah, that works. Again, I'll just make some changes so I can save that out. Oh, this one's so slow. That's cool though. Next. This is not that bad at all to just do this. Ping pong's the next one. This one is probably my favorite one that I did on the stream. Again, only drawing quads because it's stored everything in the GPU. I think it's really fun, Dark Second. You should totally do that. If nothing else, because you can, like, there's lots of different kinds of demo tools. And the fun part is doing that design and making something that works for what you want to do. Guessing this was the 21st. Yeah, it was. So that worked. Gotta set the initial state. Do that. And we can play Pong in the tool. It's still so cool. Radness. Okay, the last one in the tests, and then I could do the demos, was Loop Study. This was the particle-y QB thing. That was fun. It even made its way into our Evoke live set. Being a little less careful with this now. I mean, all this is in Git anyway, so it wouldn't hurt to mess this up. I guess this one was in June. Yeah, that would help, Dark Second. Here's the loop study project. And that, of course, works as expected. Very nice. So that's those ones, and then we have the actual demos. Now, Almost Infinite was the version of the tool before building the operator grid, so that's just going to be out of date anyway. Elysian, we'll do that one first. This one's the one that's actually going to use several different primitives. So this is going to be, I think, the only somewhat annoying one to do this with. But that's not going to be too bad. Just go through each of the different primitive types. So now the one thing that I'm still not resolving from the project directories is the music file that the tool uses. That's still in the tools asset folder, which is kind of annoying because that means all the demos that I play with right now have the engaged music when I'm using them in the tool. But I've been thinking about doing our own sequencer for a long time anyway. Like I always wanted to do that, but I used Rocket because it was convenient. Exponent, I could probably do sed, but I'm not gonna because I don't know sed, and building the expression is gonna be more annoying than just doing it by hand. Anyway. Yeah, I've been thinking about doing our own sequencer anyway. And I think sort of fixing all of that at the same time makes sense instead of trying to fix that with some sort of half-assed solution first. So yeah. I know this stuff's not the most exciting stuff to watch, but this is a big part of how we're doing demos these days. Yeah, or something like that anyway. That might have been all of them. This looks correct. Definitely correct. We'll also do one of these. Do a couple changes to save that out, just to make sure. I'm just going to go through each scene and make sure they're okay. And then when we get to engage, that's just going to use quads again. Thanks, X-Pointer, but I'm just going to keep doing it by hand. This is correct. You also notice this looks a little bit different than the actual release demo because I think I mentioned this several times, but the primitives are actually inside out in the real demo. It's pretty funny. Funny how not weird it actually looked that way. You can definitely tell the difference when you know. I think Elysian's pretty. Hey, says, do you think the more generic opcode compresses better or worse, or doesn't matter? I would say it doesn't matter. I honestly don't know though, because it's a 2-byte sequence rather than a 1-byte sequence, and like in terms of like the thing that's gonna matter more is not that fact. It's gonna matter the context that they're in and where they're used. So I think it's not really gonna make a difference. Experience what does being inside out affect? It's I can show you. Let me open Rocket again. Whoops. That's super funny. I accidentally double clicked base instead of the Rocket editor, like the DLL, and it opened a debugger. That's actually cool. It's just instead of showing the front faces, it showed the back faces. And you can't really tell due to those kind of primitives, which is kind of the funny part. That's cool, Coaster. You can't really tell unless you know, because the shapes are they're not perfectly radially symmetric, but they look really similar when they're inside out. Just a little bit of perspective that ends up being different. But yeah. That's mainly the difference, is that you either get the front of the hull or you get the back, and in the actual released intro you get the back. You can only really tell when they intersect, because if they intersect at the front, you'll see something like this where they kind of intersect like that. But when they're inside out, they do something like this. So you see kind of 4 faces, whereas here you see 2, if that makes sense. That's the main thing there. Engage is next. Thanks, Mr. Toe. That should be it for that one. I think it only ever drew quads. These projects take a little longer to load due to shader compile time. Of course, we'll go through the whole thing here. Just to be sure. Yep, it all works. Cool. And then we have, I think, the last one, which is migraine. Still a demo that we should release publicly, but it's kind of cool to have a secret one. This one I also think will only use quads. I don't know why I felt like I needed to rebuild the tool there. Again, we'll do this change thing and save it back out. I don't think I did that for engage, but that's fine. And everything here is, of course, quite all right. Cool. Everything works. It actually feels pretty good to get that done as well. Local hoster. Almost Infinite is a little hot volume-wise in the YouTube video, at least compared to Elysian Engage. Didn't get to run it myself. Was it the recording or was it intended to be almost 0 dB all the time? It was actually intended to do that. It was meant to be super loud. Generally, the streaming music stuff that we do that's not with the 64K synth, I tend to push things pretty hard when doing just big, loud EDM tracks like that. Makes it a little bit bad with the dynamics between our different demos, I guess. But that's not really... Like, we're aiming to maximize the experience for a single demo at the party, and that kind of stuff does actually make a difference. If you compare, for example, our track from... Our Hellbound track from Tursock, you'll see the same thing. And actually, even our 64K tracks are a bit dynamic between each other as well. Engage isn't pushed nearly as hard as Backscatter. And that's something that actually Hoffman is going to level out a bit for the Wavesaber release, which will probably include something cool. So yeah, it was intentional. Bam. And I'm on fire this weekend. Just blasting through these things that I put off. And then we'll need to push in Logicoma demos as well. It's all going to be the same change over and over again. Just looks like it's scrolling. That's cool. Nice. So I actually finished up 2 tickets on stream. That's actually pretty cool. I think because I'm still in the mood to keep going. So there's one other reason why I actually wanted to make this change. And that's that right now, our primitives, they only draw a single primitive. So you only get 1 object per draw call, which is really, really crap. It's very convenient if you're going to describe a lot of structural things with this kind of graph, but it scales extremely poorly. And that was an intentional design decision too. It's like, I know this is going to be slow, but we can kind of work around it. You can see how many of those we actually get away with in, for example, Almost Infinite. And also Elysian, which is just doing each object in 1 draw call, which is, I know it's shit, but it's totally fine. But one of the things that we can't really do with that is we can't do like an effect with 1,000,000 particles, for example. It's just going to be too much. And I want to fix that. And the way I want to fix that in particular is I actually just want to go in all the ops. And so we just did the primitive op. And in addition to having an expression for the primitive type it draws, I also want to do... Well, I don't actually have a CPU particle engine, but you could build one in the operator graph. That's kind of the idea. But totally want to move that to GPU for several reasons, one of which I'd be able to code it in shaders, which would make me a little more comfortable, and also store all the state in texture objects, which would be really nice. So what I want to do is the primitive currently now takes the primitive object that it draws. I also wanted to take an instance amount, like a number of instances. And then I just wanted to draw the same primitive with a bunch of instances. And then in the shader, we'll get an instance ID or an instance index that we can use to differentiate between, for example, which particle does this quad belong to. So definitely going to do that. I don't know if I want to do that now, though, because I have to also write the shaders that will test that. and kind of don't feel like doing that right now. But actually, let's do the. I know what I want to do. When I was in the JIT, I noticed we go through EAX a lot. And some of this stuff is nice. Like we do still need to be able to push EAX in particular. But there's a lot of these where it just goes through EAX for not really a very good reason. Like this stuff, I think is crap. In fact, I wonder if it does this for all, every time it moves EAX with immediate 32, if it just pushes it after. It looks like it does. That's crap. Just gonna vet to make sure it does this every time. We didn't loop around already, did we? Yeah, we did. So what I'm going to do is I'm going to replace this. So this is really easy to do with this JIT. Instead of move EAX immediate 32, we're going to push immediate 32. And I believe this was 6.8. I'll look it up again, but that's just what I remember from earlier. This JIT is so easy to make. I mean, there's a lot of parts that weren't easy to figure out, but like it's nice to modify nowadays. So yes, we push this, and then this will cause a lot of compile errors. So we need to find all these. I think I can just do this. And so at least take care of a lot of them. That's why. Because we skipped the arguments here. That's fine. I can just go and do these by hand. Don't really mind. I want to make sure I see the first one. This is also one of those things that's not going to affect things too much, but it just seems wasteful otherwise. And while I'm in this clean stuff up, refactor stuff mood anyway, should capitalize on that and fix stuff like this. I like to do that. Sometimes I'm not the most consistent guy when it comes to what I feel like doing, especially on free time projects. So I like to just kind of let this stuff build up and then, yeah. Oyster Tube says, how do you call Rust function in your x86? I'll show you that in a sec. It's really simple. If I forget, please yell at me. But I will totally show you that in a second. We'll make sure this works and then I'll show you. Actually, I'll probably have enough time while it's building to show you. Whoops. There. So the way I call back into Rust is really simple. So I have all these functions down here, which are just implementations of stuff, and I make them std call. And what that does is that allows, that forces this function to actually clean up values on the stack. Yes, Dark Second, I was totally gonna do that as well. So here, what I need to do is, like, to call this function, you need to push all the arguments in reverse order. So we push the primitive, push the context, and then use a call instruction in x86. And then if this were, for example, cdecl, then we would also have to pop those back off the stack after the function call. But this allows, this forces the compiler to pop all those off, within this function so that we only have to worry about pushing the arguments. So if we look at where one of these is used, for example here, that's literally all we have to do. Push the immediate, push EBP, and then we call, and then we just need a pointer to that function. And in this case, that function is just this here, like the name of the function, and then we cast it to this extern std call, this function type. And that's it. And we transmute that and we get a pointer. There's some unsafe stuff, but yeah. So it's literally just a call instruction into that function. And this, like I said, this could be cdecal or some other calling convention, but this one just forces the Rust compiler to deal with the stack cleanup, which makes it a bit simpler. So it's no fancier than that. I try to keep this stuff as non-fancy as possible is kind of the idea here. So the fact that this works is a really good sign. I'm going to actually test with engage in Elysian as well, just because I know that they use more operator types, and I just want to be quite sure that this works. Simpler things are, the less I have to maintain them. So strive for simplicity. The reason, by the way, why std call is often used is, for example, Win32 uses it for its libraries. And the reason they do that is that then the idea is that the library code, the code inside the DLL, will do all the stack cleanup. And then all of the programs that use those DLLs doesn't have to. And the idea is then that overall throughout your system, you will get smaller code because it only has to do that stack cleanup code once per function rather than once per call site. And it can just do that in the system DLLs, and then the programs can not worry about it. I honestly have no idea how much that saves, or maybe it's misguided and doesn't save anything. I have no idea. But that was the idea that's behind Windows using those. Just kind of fun. Yeah, so this totally works. I'm convinced. I am going to do one more test with this, though. And that's an export test. Always like to go through these. Oh, that's a cool statistic, Tourist. I'd love to hear some more of those. Oh yeah, due to the libs not being std call. 1 line out of 6 is at ESPX. That's crazy. That's totally the smallest way you can clean up the stack, though, because I guess that's going to be a 2 or 3 byte function instruction, but still, that's for every system call or every library called. So that's pretty crazy. Granted, std call can't do things like var args, but those are relatively rare anyway. So yeah, so I'm just going to do a quick export into the replayer here. You can see the export was successful. So then I can go in Rivet, cargo, run, release, and this will just ensure that the JIT still works from the tools perspective, which it should, because it didn't change any top level stuff. The JIT code itself is within the same, like it's one library, and the tool and the replayer both use that. So yep, it works. So this should actually be slightly faster. Arguably, it's probably not going to be actually faster, but it will produce a bit smaller code. Although that's just totally not a bottleneck at all in this case. I think std call uses the FPU stack for those. I don't know what it does for SSE. In the case of this system, it uses the, like, there's only one or two cases where we even pass floats over that boundary, like all these rotate ones. I guess there's more than one or two, but yeah. And for those, I think it just uses the FPU stack. So I don't use any SSE in this. Yeah, FSTP. So this right here. Oh no, this actually uses the stack. Yeah, never mind then. This is yeah, exactly what Turris says. This is actually using the normal stack. This is pushing EAX onto the stack, which would be, in this case, it's just a lazy way of doing sub ESP4. This is actually a smaller instruction, I think. I think push EAX is one byte. Yeah, push R32 is 50 plus RD, so that's going to be a 1 byte opcode instead of 2, and then it stores ST0, which is the top of the FPU stack, and pops it, so it stores it into where ESP was. So this just clears out 4 bytes, then it stores it, and then it pushes the context, and that's how it gets that argument there. I think it does the same thing when it returns stuff. Where it just returns an EAX. It's like random pull. No, this must return into ST0. So the return value for std call, I think, is it returns an ST0. Repnop, yeah, I did write it from scratch. Dark Second using x86 due to built-in syncause. Actually, it was because it's really easy to compile code for a stack machine. If I use x87, then I can just, it's very trivial to generate the expression code because I can just rely on the stack being there. If I were to use SSE, I would have to do register allocation. So it was actually for that reason. Also, like, it would have been harder to actually take advantage of SSE in this case because all of the variables are just single floats or doubles, actually. I do them in 64-bit. And vectorizing that would have been difficult, I think. I think if I were to use SSE, then I would do everything as like float fours. Yeah, I probably should do a write-up on the JIT at some point. I mean, what's kind of fun about it is that it's actually like really straightforward. But yeah, it's still fun to do. Yeah, I could use a fake stack, but I didn't want to do that. Yeah, I mean, I guess I could have just like just had my own stack for when generating the code, and then just each stack position would correspond with an SSE register, and that would work out easy enough. But yeah, I think you end up with more data dependencies than you would like. Anyway. Like, I can show you the part of that writes out the expressions. It's in the compiler here. It's in the end here at the code gen. So here, this is where it's going to emit code for an expression. And so the nice thing about stack machines, like, oh, you have a constant, we'll push that. If you have random, push that. And then things like a unary op, for example, negative, it's just going to pop the thing off the stack, pop the value off the stack, do the operation, then push it back on. And then bin ops are going to, pushes left, pushes right. And so the bin op will pop right, pop left, do the op, and then push the results. So this actually wasn't what I wanted to show, the generate code. I actually wanted to show the JIT code here. Neg. Yeah, and these map just directly to x87 calls. Here, for example, constant reads the U32 value, which it just gets just by interpreting the bytes, pushes that onto the stack, and then the FPU will load that off the stack. And here we also do pop EAX just to adjust the stack again. Kind of a lazy way. But yeah, all these map super simply, which is kind of nice. I mean, since we have full knowledge of the expressions, doing SSE and doing register allocation in the compiler would totally be possible. But it's just, I don't have to do that. I'm still talking about it because I find it interesting. But let's do that cleanup in the compiler. Where was it? Here. No, it was in the parser. So I did actually clean up the compiler. I didn't clean up the other day. I didn't clean up the parser. That's where we ran into this. So this is really easy. Have to replace all the instances with try with this stuff. This is weird. Oh, it probably probably gets an option or something out of that after doing parset. And I'm guessing this is going to be a safe thing to do. Yeah, because it finds the positions of the subroutines and then makes sure it parses something there, and then there's always going to be an op there. So that is actually a correct unwrap. Here again, I want to do them by hand because I don't think, I could be wrong about this, but at least in many cases, the try is not necessarily the end of the expression or the end of the line. So I'll at least want to look at these as I do them, but looks like I can do a lot of these as sort of groups like this. Reason I just did all those instead of keeping going was so that I can, if suddenly there was a surprise one that didn't follow the same pattern, then that would have been annoying. Yeah, so here I'm right, because like this one, the try isn't the last expression here. So that's why. Tourist says if you did static register alloc, you'd also have to store register numbers. That's definitely true. Like the bytecode would have to contain that information. And I don't think that would hurt things too much. I mean, the bytecode is just ridiculously small anyway. But I actually do remember Blueberry talking about that when we were discussing this, now that you mention it. So I don't think that was I didn't make the decision for that reason for sure, but you're absolutely right that we would have to. And with x87, you're right that we can just ignore it. T-Nichols89, how did you originally learn to write emulators? Just by doing it. I think I found a few articles a long time ago. There was one. Yeah, I can't remember, honestly. There's a lot of guides now. But I think it's the Marat Faizulin one. Like here's a link, for example, that I definitely remember reading. I don't know, like, because I kind of feel like I haven't written that many emulators, but I have been doing it a little bit over a long period of time. And I've written a lot of, what's the word? Like interpreters, or in this case, a JIT for something. Like, they're all kind of the same things. And then I've done a lot of coding for old school hardware. So I can't remember when I started picking up the information to start writing emulators. I remember the first time I started working on an emulator was in 2011 or so. And that was a Atari VCS emulator that I didn't get very far with. At this point, I don't think I would consider myself an expert on the subject. But it's something that I do that I stream. Thanks, man. Man or woman? So funny with some of those words they just use by habit and realize, oh, I'm inadvertently assuming someone's gender. What else is here? Yeah, a lot of these other tickets that I have on the tool right now, I don't want to do right now. In fact, I should probably call it quits anyway due to the time. Yeah, it's 10:30, so that's a 2.5 hour stream. That's a good one. I'm gonna play with undo redo and stuff a little bit more, because it just makes me so happy that I can do it now. Yeah. Cool. But yeah, thanks guys for hanging out, and I will see you next time.